Next up, we have Brandon Goodell, who's going to chat with you about why it's so difficult to bolt privacy on after the fact. He's also a researcher at the Monero Research Lab and quite the veteran himself, so hope you enjoy.
Thank you, Paul. Also, thanks to Frost Brown Todd, which I always forget how to pronounce, or the order of the words, and thank you to Hashed Health for hosting this event. It's been really fantastic. Can everybody hear me okay? Am I too loud? Okay. Today, it took me a couple of days to figure out what I wanted to talk about for this event because there is a spectrum of talent and interests in this room, and I wanted to make sure that I try to hit everybody. Not literally. Our previous speakers have spoken about privacy pretty thoroughly, so guess what I'm talking about? Privacy. What I decided to go down to is to give you guys some intuition about why it's hard to do what Aaron was just talking about, which is ripping out a component that is transparent and replacing it with something that's secure, okay? We're gonna call this the rabbit hole talk, okay? So the way that this works, everybody is aware after the past two talks that the Bitcoin blockchain is totally transparent. And in fact, just the other day, I was at a conference in Stanford and I overheard somebody say something like, oh, I'm sure Bitcoin will be private eventually. It will have like technological developments that'll make it just fine, right? Mimblewimble will save us. Confidential transactions will save us. And this is a really fantastic sentiment, but unfortunately, I think it's wrong. And it doesn't mean I'm right, but I think I'm right. And I think that it's not just wrong, but it's wrong-headed because it has the problem inverted, right? What you're doing is you're saying, oh, we have this nice transparent system. It does exactly what we want it to do. You can transact with people in South Africa. Awesome. Now let's make it private. Can't do it that way, okay? So I'm gonna put an example on the board that literally everybody in this room knows. It's a check, right? So if you have a transaction, what does it look like, right? It has the sender and the receiver and an amount and a date. And if it's a check, it also has your account number and your routing number. And so that's like everything that you need to drain this guy's account right there. Oh, and it's in the form of an IOU, which Sarang pointed out to me the other day. Actually, it was earlier today. And not only that, weird information is leaked that you don't think is important, like the check number, right? If this is John sending a check to Mary, then whoever looks at this check is pretty sure that this is the second check from John's account, right? Everybody can agree? Okay. So the important part about this is that, as mentioned earlier, a Bitcoin transaction is like shouting all of this information into a public square and then hoping that everybody checks all of their ledgers and verifies that the transaction is legit. And there's a lot of problems with this. There's a lot of information that leaks, okay? Obviously, we've gone over this several times tonight, right? The identities of the transactors and their account numbers, that's leaked, right? And we can try to fix that as we do in Monero. Actually, first we can try to fix it like they tried to fix it in Bitcoin, which is replacing your like home IP address with a Bitcoin wallet. And everybody's like, oh, this random string of digits looks random. Who knows what that could be? And then these people start using Coinbase and they fill out their KYC forms, and then Coinbase knows everybody's random wallet addresses, right? No more security. A random wallet address looks just like a real name as far as security goes. So maybe you just generate a completely new random key for every single transaction. Awesome, cool, we fixed the name problem. Next, how do we fix the amount problem? Well, we're going to mask the amount with homomorphic commitments, and we're going to prove that they're legitimate amounts with range proofs. Okay, great. Next up, the forgeable signature. I didn't mention this on the previous slide, but everybody in middle school had a report card come home, and they like rushed home to try to intercept the mail before their parents got it, and then try to forge a signature. At least I did. I'll admit it. And then, of course, finally, you have this permissioned and censorship-sensitive system where, on the previous slide, we had this check from JP Morgan Chase. That's not going through if JP Morgan Chase doesn't want it to. Sorry, you need permission. So how do we fix that? Well, we can remove the trusted third-party TTP and do the classic Bitcoin solution. Decentralize all the things, make verification decentralized, and allow anybody to broadcast. Decentralization of verification kills the third party. Everybody broadcasting removes the permissionlessness, and then adds permissionlessness. Anyway, and then there's the date problem, right? The date at the top of the check. This is not a problem that we have solved. You always have to stuff that transaction into a block. Unless you have some coin join thing happening, dates just can't really be masked. So if you have a totally transparent system in the first place, there's sort of like cryptographic tricks that you can do to plug in and replace all of the components of the check, and you get something that seems like a private system. And then you're thinking, oh, okay, we got a private system. We're good to go. Wrong. By making every single one of these changes, you've introduced new problems that have new trade-offs. And now we're down the rabbit hole. Okay, so let me give you guys an example. The one-time keys, they can still be clustered, right? Just because they're one-time and random and they're never used again doesn't mean that they can't be clustered by Coinbase. So, okay, how can we fix that? Well, maybe instead of signing with one key, we can sign with 11 keys, like a ring signature. Or maybe instead of signing with one key, we can sign with the entire Zcash blockchain in a snark. Okay, problem fixed? Not sure. Next up. Actually, the amounts are good. The Peterson amount masking of confidential transactions is a fantastic piece of technology, and really the only problem is implementation issues with that one. If you do it correctly, you're good to go. So actually, that's like a branch in the rabbit hole that comes to a terminal point, right? And then if we decentralize all the things, then we have proof of work that's securing the chain, right? And that requires burning resources constantly. And even if you think that proof of stake is the future, or proof of stake is the future, there is a website where you can upload a picture of a stake and get a coin. Even if you think that's the case, they're not currently functional enough to replace proof of work. So in the end, you haven't really solved the decentralization problem even. And in fact, the trusted third party deal, you didn't really fix that either. The banks is replaced with an exchange now, right? Instead of JP Morgan Chase, I have to worry about Coinbase. JP Morgan Chase was previously the one who was making sure that all my transactions were going through, and now it's Coinbase. Oh, but Coinbase is like a custodial exchange. We shouldn't be using Coinbase, not your keys, not your coin, right? Okay, but you're still trusting the miners to relay your transactions. You're trusting that half the network is honest, right? So your trusted third-party model changes. Every single threat model that we saw earlier in the transparent case totally changed. And it added more problems. So, okay, now we're gonna go through and try to fix every single one of these problems with new cryptographic techniques. And then we're gonna try to fix all of those problems with new cryptographic techniques. And we're gonna have an infinite regress. And in my humble opinion, I think that's what Ethereum has seen with Casper over the past couple of years, right? They try to fix proof of stake with one thing, it causes a problem. They try to fix that, causes another problem, and it just never really goes anywhere. So, too long, didn't read. If you try to graft a private system on top of a transparent system, things tend to go wrong. And there's not an easy way to rip out the components from these transparent systems like Bitcoin and replace them with private systems. So if you're gonna be running a digital asset protocol like Tari, you need privacy on that base layer. Otherwise, you're not gonna have privacy on any layer. You can't build a private layer on top of a transparent layer. And hopefully after our little discussion, which I kept short and kept the technicalities to a minimum, you guys also have a little bit of intuition about the engineering challenges that show up when you try to fix something that seems to be leaking too much information. The only way to win is to not play the game and to start at the base layer with privacy. And that's what we try to do at Monero. And with that, oh, yes.
In doing so,
So if you're on off-ramping into, okay, so the question for the audience who didn't hear that or for the video, the first question is, can we address security a little bit to see what the security of Monero looks like? Isn't Bitcoin the most secure chain because it has the most hash rate? And then the second question is, if I want to go buy a house, how am I going to offload that Monero into US dollars without totally revealing myself? I'm going to answer those questions in inverse order. The second question, which is, how do I get out of Monero without revealing who I am? I'm going to say you can't. If you're holding on to some private technology and you're forced to reveal it, you're done. If you're buying a house in Maui, you should invite me, but you are inevitably going to be revealing your identity, at least to the banker, right? And then the first question is Bitcoin, oh, I'm sorry? So yeah, so the real solution is like business trickery, right? Is like to go to the Panama Papers, right? It's totally legit and legal. I didn't mean to use the word trickery in a negative sense. But your second question in terms of security for the hash rate, actually, I'm going to hand this off to Naveen because one of the ways that you can improve security, depending on who you talk to, can be merge mining. And Tari is one of these services that merge mine on top of Monero in an attempt to try to bootstrap the security of the Monero blockchain in addition to the Tari blockchain. So I'm going to hand it over to Naveen right now. Yeah, everybody, this is Naveen Jain.